So now let's look at a linear inequality. Now, first thing, let's remember that the word inequality, the key is this point here. It's inequality, meaning not equal. So when we're dealing with inequalities, that's when we're dealing with greater than, or dealing with less than or equal to. Let's remember from grade 10, graphing a linear inequality with a single variable. So if we got to this linear inequality and you're asked to graph it on a number line, we would take our line and we would draw in our number line. We would pick our 0 point and we would go 1 and then 2 and then 3. And remember, a number line goes both positive and negative. So we got -1, -2, -3. Now, if we have x is greater than 2, what we want to do is we want to go to the point x equals 2 and put an open dot. And remember, the open dot tells you that we go up to 2 but doesn't include 2. Now, what we're going to do is we're going to shade everywhere above x equals 2. And we're going to try and do an arrow that says we go that way. Now, if we had x is less than or equal to 2, it would be the exact same thing. I'm going to just sketch a number line in here. And we don't have to put all the points in. We can just throw in these values. And if it's equal to, remember, that's when we need a close dot. And we are going to shade everywhere to the left, like so. Now, that's single variable. Now, we're going to keep that in mind because when we're graphing linear equations, or linear inequalities, I should say, of two variables, we're going to use those similar techniques. So what are we going to do here? Let's look at graphing this inequality. So how do we graph a linear inequality? It's very, very similar to graphing a linear equation. So the first thing we're going to do is just take our inequality and make it an equation. So we're just going to make it equal. And we're going to graph that equation. Now at this point we have a choice. We can do it using either the intercept method or we can do it using the slope y-intercept method. Choice is up to you. Now if we look at this, all we have to do is take the 3x and move it to the other side, and it's in the form that makes it very, very easy to graph. We have the slope and we have the y-intercept. So we go to y equals 6 and put a dot. We have a slope of -3. We go down 3 and over 1, down 3 over 1, like so. And that would be our line. Now, because this inequality is equal to, we want to include the line. Now let's look back at the last slide. Is when we wanted to include the point, what did we do? Well, we had to put a solid dot. We had to make sure we included that point. Well, that same principle applies when we're doing a line. What we have to do here is we want to include that line. We want to include everything up to including it, so we need to do a solid line. So it's just like graphing a linear equation. We just draw in our solid line. And we make sure we indicate that this line continues on forever and goes all the way up and all the way down. So that's just graphing a linear equation. But now this is not an equation, this is an equality. And we want to figure out what side. Now this line now acts like a boundary. So our solution is either to the left or to the right of that boundary line. So how do we figure out where our solution is? Well, we pick a test point. And all a test point is some value. Now, the easiest value is always 0, 0. Makes the math easy. You could pick 75 and 108, but it's just going to make the math really, really hard. So let's pick 0, 0. So we're going to take 0, 0 and we're going to put it into our original inequality. And now we have this statement. Is 0 less than or equal to 6? If this is a true statement, which it is, what that means is we need to include that test point in our inequality. So we want 0, 0 to be part of the shaded region. So we shade the side of the line that includes that test point. Just like that. There we have a linear inequality. What are the key differences? Well, the line is either a solid line if it's equal to, or if it's not equal to, we would do a dotted line, meaning we don't want to include that line, and there's always a shaded region. So that's graphing a linear inequality. So here are the steps to graphing a linear inequality, and it's really just a step-by-step method. Step 1, we just graph the inequality like it's an equation. And if it's not equal to, we would use a dotted line. So that's when it says an inequality is strict, greater than or equal to, greater than or less than, it should be a dotted line. Step 2, choose a test point. Plug into the original inequality. Now remember, we always want to use the original inequality as much as you can to avoid mistakes. If you change things around and you don't use the linear inequality that you were originally given, you're likely to make more mistakes. And let's use 0, 0. Now, let's make a little note here that 0, 0 cannot be on the line. If it's on the line, we have to choose a different point. So you can choose 1, 0 or 0, 1, any point that's not on the line. And again, if the test point evaluates to make the inequality true, then we shade the region that contains that test point, and if it's false, we don't shade that point. Now let's look at one that we have ugly fractions on. We have a linear inequality and we want to graph with fractions. So what do we have to do? Well, if you're like me and fractions are scary, let's get rid of the fractions. And remember, just like an equation or an inequality, we can multiply the entire thing by some value and it doesn't change it. It doesn't change the statement. So if we multiply the entire inequality by 3, we're going to get this. X plus 2y is going to be greater than or equal to 6. And that one simple step has taken those ugly fractions and made them disappear. And now we would do the same thing as the 3 steps. First we take our inequality and make it an equation. Now for this one, I'm going to switch it up and I'm going to do the intercept method. So when x equals 0, I can see I get this statement, 2y equals 6, so y is going to equal 3. And when y equals 0, we're going to get this statement, x equals 6. We go back to our graph and we put these values on. At x equals 0, y is going to equal 3. Now it's a little tough here. Let's see, we're right about there. And at 6 and 0, we are right here. Now before we connect the dots, we check to see that yes, this is an inequality that is equal to. So we need a solid line. So we draw in our solid line, just like so. We want to find a point and test it. And so let's choose 0, 0. So we're going to put 0 over 3 plus 2 times 0 over 3 is greater than or equal to 2. Remember using our original inequality? Now this all boils down to 0 is greater than or equal to 2, which of course we know is a false statement. So 0 is not greater than 2, so we don't want to include this inequality, or we don't want to include this point, I should say, in our inequality, so we shade everywhere above the line, just like so. So that's graphing a linear inequality.